All right, let's talk about a real legend in computing history, the Intel 8086. Now, this is the chip that basically set the stage for the personal computer as we know it. But the really cool thing about it, the thing that makes it so fascinating, is its built-in split personality, a design choice that gave it some incredible, and I mean incredible, versatility. And that really is the million-dollar question, isn't it? You see, back in the late 1970s, Intel's engineers had this huge problem to solve. They needed to design one single, powerful 16-bit processor that could fit into a simple, cheap system and a super complex, high-performance machine. So how on earth did they pull that off with just one chip? Well, the 8086 didn't just appear out of nowhere. It was this massive leap forward from its 8-bit predecessor, the 8080. This new 16-bit architecture was a total powerhouse for its time. And just a few years later, its close cousin, the 8088, was picked by IBM to be the brains of the very first PC. And that, my friends, is what kicked off the whole revolution. On the inside, the 8086 had some serious muscle. What you're looking at here are its general purpose registers, AX, BX, and so on. And for doing 16-bit math, these were a huge deal back then. So yeah, the chip had the horsepower for complex stuff, but its real genius was how it played with others. So what was Intel's brilliant answer for conquering two different worlds? Oh, it was beautiful. Just elegant. They added one single pin to the chip called the MN/MX hash pin. And by connecting this one little pin to either a high or low voltage, you could completely change the chip's personality. You could switch it between what they called minimum mode and maximum mode. So let's start with personality number one, minimum mode. The best way to think about this is to imagine the 8086 as a self-sufficient solo artist. It's perfect for those simpler, more self-contained systems where it's the only star on the stage. To get into this mode, all you had to do was connect that special MN/MXPresh pin to a high voltage, what engineers call a logic 1. In this setup, the 8086 is the undisputed king of the castle. It's designed to be the one and only processor, running the whole show all by itself. Now, the reason this solo artist mode was so great was that the 8086 generated all of the critical control signals itself. What does that mean for a system designer? Well, it means you needed fewer external chips, which led to designs that were way simpler, a lot cheaper, and just plain easier to build. Just perfect for those first PCs or for dedicated little embedded systems. But what if simple wasn't enough? What if you needed more power, more complexity? Well, by flipping that one single pin, the 8086 completely transforms. It goes from being a solo artist to being a conductor, leading an entire orchestra of chips. To get into maximum mode, you connect that very same MN/MX sharp pin to low voltage, a logic 0. And when you do that, the 8086 becomes a team captain. Its whole job changes. Now it's designed to manage a whole crew of helper chips or even other processors in these really complex, high-performance systems. So here's the key takeaway for this mode. The 8086 doesn't try to do everything itself anymore. It's smart. It offloads the nitty-gritty work of generating control signals to a specialized buddy chip, the 8288 bus controller. It's like a CEO delegating tasks, right? This frees up the 8086 to focus on the big picture, like coordinating multiple processors in powerful servers or early multitasking computers. Okay, so we've got the solo artist and we've got the conductor. How do these two personalities really stack up against each other? Let's break it down. You know, when you get right down to it, the difference is all about one simple idea. Is the processor a self-sufficient solo act doing everything itself? Or is it a team manager delegating tasks to get a much, much bigger job done? And this table just lays it all out perfectly. You've got minimum mode, which gives you simplicity and a lower cost, and then you've got maximum mode, which gives you all the raw power and flexibility you need to build really complex systems, but, it comes with more complexity. This choice is exactly what made the 8086 so incredibly adaptable. So to really see this difference in action, we kind of have to peek under the hood at how the 8086 actually communicates. Let's take a look at something called the bus cycle, starting with its simplest form in, you guessed it, minimum mode. Every single time the 8086 needs to read something from memory or write something to it, it follows this super precise 4-step routine. It's like a perfectly choreographed dance, all synchronized to the system's clock, and it's called a bus cycle. So, in minimum mode, our little solo artist handles this whole four-step dance all by itself. In the first clock cycle, T1, it puts the memory address out there. Then, in T2, it sends out the read signal, basically asking, "Hey memory, can I have the data?" In T3, it grabs the data that memory puts on the bus. And finally, in T4, it cleans everything up and ends the cycle. Step by step, all on its. Okay, so this was a design choice from over 40 years ago. It's ancient history, in tech terms, right? So why are we even talking about it? Why does this dual mode thing still matter today? What's the real impact? Well, the answer is because this idea of a single processor design that can scale up or down for different levels of complexity, it's absolutely everywhere today. The principle of a scalable architecture, where one core design can power a simple little device or be part of a massive supercomputer, you can trace it all right back to this. This flexibility it was everything. Take how it handled memory, for instance. It had this clever trick called segmentation, where it combined two 16-bit registers to create a 20-bit address. This let the chip talk to a whole megabyte of memory, way more than a 16-bit chip should have been able to. This kind of innovative thinking became a foundation for how chips would manage memory for generations. So yeah, the legacy of the 8086's two personalities is alive and well. It evolved into the powerful, multi-core, incredibly adaptable processors we have in everything now. Think about the chip in your phone. It can run in a super low power mode to save battery, and then in an instant ramp up to maximum performance with multiple cores all firing at once. So it really makes you think. The 8086 gave you two choices. How many personalities does that chip in your pocket have today?